So I'll get my microphone located. It's always awesome to start a talk with technical issues. It's the best. So I'm really excited to be here at MCE. One of the really nice things about this conference is that it brings together iOS developers, Android developers, designers, and we have the ability to share and close the gaps between these different professions. So who here in the audience is actually an Android engineer? Awesome, that's more than I expected because there's an Android talk going on in parallel. So that's really nice because this talk is a lot about sharing ideas between different platforms and also a lot about my personal story of doing that and why I think it made me a better developer over the last 2 years. It's also the very first time I'm giving a non-technical talk. All of my other talks have been focused a lot on details of the Swift programming language, architecture, but we all know that a lot goes into developing software that is not actual code. It's how we collaborate, it's psychology, communication. And so I'm really excited to share a non-technical topic that still discusses how that has influenced my way of how I develop software. So the talk today is titled The Art of Stealing. And what I want to talk about is taking ideas from other platforms, from other technologies, stealing these core concepts and applying them to your work. And there are two core assertions that go into this talk that I want to start with. And assertion number one is that we are ignoring a huge amount of valuable knowledge outside of our immediate community. And that immediate community can be your coworkers, if you're not very active outside of your work. But it can also be people on Twitter, or maybe people at conferences that you meet. But typically, we're really siloed into these technology-specific platforms and communities. And so I mostly know iOS developers. And it's very rarely that I have a chance to speak to an Android developer. And assertion number two is that we in our industry could be significantly more productive if most developers expanded their scope of knowledge. And this here is not about the depth of knowledge, because all of you are here because you're obviously really passionate about what you're doing, and most of you probably want to learn more about iOS development. But there's also a lot of knowledge outside of iOS development happening on other related technologies, and we're ignoring that, and I think that makes us a lot less productive than we could be. And today I hope to share some good examples, some specific examples of personal projects of mine, where I really worked hard on looking at other people's work and trying to bring it to my platform. When starting to prepare a talk, I also always look for evidence of other people kind of having similar ideas, because ideally, I'm not the only person that thinks this way, because otherwise my idea is probably wrong. And I happened to read the Steve Jobs biography in the last 6 months, and I found this quote in that book that was really suitable for this talk. What Steve Jobs said, and that was part of a documentary that was on PBS, ultimately it comes down to taste. It comes down to trying to expose yourself to the best things that humans have done, and then try to bring those things in what you're doing. I mean, Picasso had a saying, good artists copy, great artists steal, and we have always been shameless about stealing great ideas. Now, if you're familiar with Apple's history and the products that Apple has shipped, then you might know that a lot of the core ideas and that made their products really successful were stolen from other companies. For example, the Apple Lisa was like the first computer that popularized the graphical user interface, but Apple didn't invent the graphical user interface. It came out of Xerox PARC. And they took almost all of these ideas and stole them, but then they applied a creative process to it to turn it into a true innovation and a great product. So Steve Jobs has this quote, and I think it's really suitable for this talk. That is also an interesting aspect because he quotes Picasso, who says, good artists copy and great artists steal. And so when I read this quote, I wondered, what is the differentiation between copying and stealing? When I think about art, then I think copying is probably an artist sitting there looking at a picture and creating a one-to-one copy of that picture in order to sell it probably for money and make a profit out of that. And that is usually what we call plagiarism. But great artists steal. And great artists stealing means to me understanding what the core idea of this picture is or of this piece of art, and then trying to extract it, applying your own creative process and creating something new out of it. So when we transfer this to software development, what does it mean? I think copying is something that a lot of us do day to day very frequently. We use third-party libraries that we just copy literally into our code base. We go into Stack Overflow, we look up answers, we copy that code into our code base. We have code reviews, and usually coworkers will tell us exactly, please change this line, please make this modification, and then we adopt that. And this is a really important step, because we don't want to do everything from scratch. That is like the baseline of collaboration and using the work that other people have done. But it's just literally taking what other people have done and using it in our projects. It's not stealing. What do I think is stealing in the context of software development? I think it's looking outside of your immediate field of work and taking ideas that you cannot directly apply, taking concepts instead of taking code. You can do that by watching talks that are totally unrelated to your specific technology. You can do that by reading academic papers, which barely anyone does, but there's actually a lot of interesting stuff in there. And you can do that by just playing with other programming languages or technologies. It turns out that every technology is really amazing at something that your main technology is really bad at. And by just understanding these kind of core components of other technologies, you can very quickly improve how you use your main technology. Now, you will maybe argue that you don't have enough time to do that, because you already go to conferences, you read blog posts, you subscribe to newsletters for your specific platform. Like, how should you have more time to look at stuff that seems totally unrelated to what you're doing? There's always this tension between time spent researching and time spent writing code. If you're a developer, you probably care a lot about your productivity. You care about how fast can I ship a feature, how many lines of code do I write per week. But when we do that, we often forget that research is really another way to enhance productivity. Even though it seems like you spend time on something that maybe doesn't benefit you immediately, that usually pays off down the road. So I'm going to make the argument that we don't research enough and we spend too much time on immediate productivity. And once again, I was lucky enough to stumble upon a piece that underlines this point. This was a post on Stack Overflow by a developer called James Long from the JavaScript community. And he created a very popular framework called PROIDEA. And he gave a talk at a JavaScript conference, and afterwards people came up to him and asked him, how do you become such a great developer? Like, what can I do to become a better programmer? And then he wrote this blog post, how I became a better programmer, and that one became very popular on Hacker News. And it had one section that specifically talked about research and doing research before you work on other projects. And he said, dig into past research. If you're excited about an idea, it's super tempting to sit down and immediately get going. But you shouldn't do that until you've done some cursory research about how people have solved it before. Spending a few days researching the topic always completely changes how I'm going to solve it. It's valuable to learn how to read academic papers. I don't know anything about denotational, operational, etc. semantics, so there are a lot of papers I can't read. But there are many that use code instead of math and aren't too hard to read. There is a huge amount of knowledge sitting in papers from the last 30 years. If you get good at extracting this, you'll be a thought leader in no time. And so he wrote this, and then he went on to talk about how PROIDEA, this library that he built, is really just an implementation of another paper that he found. So he wanted to build this JavaScript formatter, and what he did is he went out and read papers, and then he found an implementation that he could really just adopt to JavaScript. And it was a very powerful experience for him, and I've experienced exactly the same. So we have very few thought leaders in the industry, and I think that is because most developers, and this still includes myself, are spending too little time on research. I've been trying to improve this for 2 years, but there's always an urge to be productive and write code instead of going off and learning things and reading about other solutions. So you might have had bad experiences trying to use other papers or other open source libraries that don't really fit your use case. So I tried to visualize my idea in a graph as well. So let's make a little thought experiment. And let's say you have a problem you want to solve, and it's a new problem, you don't know how to solve it. I would argue there are two main different ways of how you can approach solving this problem. The one is you take the knowledge that you have today, and you start working, and you work on improving your solution. What this graph here shows is an x-axis with an incorrect and a correct solution, and each solution will land somewhere on the spectrum between incorrect and correct for your specific use case. And I assume if you start from scratch with the knowledge you have today, you're going to start in the middle. The solution is neither incorrect nor correct. You're going to spend all of your effort improving it, and then you're going to end up somewhere to the right on the x-axis. But then there are also other solutions out there. And so instead of going off and writing your own solution, you could spend time looking at these other solutions first. And these other solutions are the blue dots. And they can be all over the landscape. Until you investigated and did some research, and maybe even some prototyping, you don't know if these other solutions are suitable or not. And so what happens a lot, I think, is that people spend time researching solutions, and then they find these blue dots that are on the wrong side. They're like far off, and they're just totally unsuitable for this problem that people want to solve. And so they conclude that they wasted a lot of time looking at these solutions, even though they're not suitable. But then there are also some blue dots that are usually pretty far on the right spectrum. And I think if you research enough and you look at enough potential solutions, you will typically find something that is pretty far on the right side already, often further than you could do by just applying all your effort on implementing your own solution. So I'm arguing you should take that effort that you use for your own solution and spread it across different other solutions, spend time researching and prototyping, and find out how much time it would take to adopt someone else's solution. And this is not about adopting the code, it's just about adopting the ideas. And I'm going to come back to that in a second. I want to share some personal examples. I said that this talk is a lot about kind of my personal growth in the last 2 years through this changed mindset. And so I want to show you some of the projects that I worked on. The first one is a project called ReSwift, and it's an implementation of the Redux library that you might have heard about. And Redux originally comes from the web. And I got introduced to Redux through a coworker who is a JavaScript developer. And he was watching a talk from the F8 conference, and he recommended a talk to me, so it was really coincidental. And I don't want to talk too much about the technology behind this, but I watched this talk, and they talked about how they introduced this new technology for developing web applications at Facebook, and how they solved a lot of the complexity that I had with MVC before that. And after I watched that talk, I felt like all of these ideas also apply to all the iOS apps that I worked on before. It seemed like there's really no distinction between web and iOS or Android for that matter for this particular technology. And so it took me almost a year to take some time to look into that, but then I decided to spend a week and just build a prototype and see if I can implement this pattern on iOS. And this is what became ReSwift. It really took probably 4 or 5 hours of watching this talk, talking to the coworker, and then a week to build like the core library and some developer tooling around it. And one of the really cool things about Redux is a feature called time traveling that enables you to record all the state changes in your app and then travel through these state changes back and forth. And so back then, after that 1 week, I built this demo where I had a very ugly-looking sample app. But what was really cool about it is I could time travel through that. You can see the video here on the right. So this is like a very simple Twitter client, but I can travel through time, and I can see all the user input and how it changes, and all the network responses, including navigation. And this was really awesome. I was like, wow, I was really excited about this. And when I shared it with people, they were excited too. And they came up to me, like, wow, how did you build this? This is all amazing. And I said, well, I just looked at this other solution. I literally translated JavaScript code into Swift code. That was like the first step. And then later on, I did some changes, and I applied some creative process. But really, I just took this idea that was kind of standard in the JavaScript community and took it to iOS. And people were amazed because they didn't see that technology in their space before. And the story goes even further, because Redux is actually not an invention by itself. Redux is an implementation of the Flux pattern. So Facebook invented Flux, and then Dan Abramov implemented Redux on top of it. And he also wrote a blog post after he gave a talk where he introduced Redux, where he mentioned his inspirations for the library. One of it was obviously Flux, on which he based his solution. But then he also mentions a lot of talks and other open source projects that inspired him. And one that really stands out to me is a talk called Turning the Database Inside Out. And if you haven't seen it, it's a really, really great talk. But what is amazing is that it's a talk about a database system. And he used the idea from this database system to build a UI framework. And it's possible because all these ideas in software engineering are much more related than we often see. And when you spend a lot of time researching and exposing yourself to other solutions, then you start to see the connections between them. And then I was on a roll because I was like, yes, I built my first successful open source project. This is amazing. Let's do more of it. I don't do that anymore that much, but 6 months later, I was like, I want to do something again. And so I was reading this book called Type-Driven Development with Idris. Who has heard about Idris before? Very few people? Yes. It's an extraordinarily esoteric programming language that is kind of popular in a subset of the already esoteric Haskell community. But I got interested in it because I transitioned from Objective-C to Swift. And one of the really interesting transitions that you do when you go through that is you learn how to use the type system. And so I got really excited about Swift's type system, and I wanted to learn about other languages that have even stronger type systems. And Idris is known to have like the most expressive type systems of all languages. And so I started reading this book, and actually ever only managed to read 60 pages. But in the first 60 pages, the author of this book, who's also the author of the programming language, managed to describe like the core concept of the language that makes it stand out from all other ones. And that is the concept of a dependent type. And I'll quickly diverge into some technical talk for the next 2 slides, and I'll come back to non-technical again. But a dependent type basically allows you to express something in a type system that in most programming languages you can only express at runtime. For example, you can write a function that takes an array that has 20 elements, and you can define that in your type system. So the compiler will ensure that you can never call this function with an array that has 19 elements or 21. And that's kind of a mind-blowing idea, because all of these things that you can usually only validate at runtime, you can now push to the compile time. And I was really excited about this idea, and it was really well expressed in this book. And I knew I can't really do this in Swift, because Swift will never support dependent types. It would be like a huge change to the compiler. But I wondered if I could take this idea, the core of the idea, and apply it to iOS development in some other way. And so after playing around with the idea for a little bit, I came up with Validated, which is a very, very small library. And what it allows you to do is very similar to what dependent types in Idris allow you to do. You can, for example, write a function that is called logout, and it takes in a user. But that user has to be of a specific type. In this case, it has to be a logged-in user. So I want to express in a type system that this function can only be called with a user if that user is logged in. And a user being logged in is obviously something that belongs to the value and not to the type. But with Validated, you can make it belong to the type system. And the way you do that is actually very simple under the covers. There's a validated type that takes two generic type arguments. The one is the base type, which is, in this case, the user. And the second is a validator. And that validator takes a value of the base type and checks if it conforms to your validation. For example, in this case, the logged-in validator will be a function that takes the user and checks if that user is logged in and then returns true or false based on that. It's very, very simple. But what this gives you is you have now defined a new type. And when you create that new type, then there's a possibility of failing creating a value of that type. So the validated library provides you with an initializer. And that initializer on that new type takes a value of the base type. So I'm creating a logged-in user with a regular user. And if that regular user meets the requirements, so if that user is logged in, then I successfully create a value of the logged-in user type. And if not, then Swift will throw an error that I have to catch. And now this is obviously totally different from Idris because it's not a compile time, it's a runtime. But it allows some of the similar benefits. I can now write functions that take this specific type. And in the type, I have defined a contract. I've defined further specifications of how that value should behave. And so I get a lot of the same benefit, but it's not the same core idea. So that was the second example that I got really excited about. And then something interesting happened. You can't read this on this projector, but the text is also not too important. Someone came onto this repository, so this validated library also became somewhat popular. And then Logan Wright, who's one of the core contributors to Vapor, which is a Swift web framework, commented onto the library, and he opened a pull request. And he suggested back some changes because they started using this validated library in their web framework. And this was really cool to me because I've basically spent like 2 or 3 evenings reading about dependent types. And then I built this very small library where I wasn't even sure if it would be useful. And then it just ended up in this pretty popular open source framework that is now used in a lot of web applications written in Swift. And they also changed a lot of my ideas. In the end, we actually didn't even merge back the pull request because the idea of how they use validations changed so much from the core library. So this idea just got transformed another step, and it really shows the power of looking at other people's open source libraries and solutions and applying your creative process to them. So I said I also want to talk about the practical part of this. I can't really share a recipe. I don't think it will work for everyone, but I can share what I tend to do and what I've tried to do more in the last 2 years. So the first, most important thing is really a new mindset. Whenever I have a new idea or a new problem, I always assume that someone has solved a similar problem before. I never go off and write code immediately. I always do research as a very first step. And then the second thing I realized is that some group will always have more resources focused on this. For some group, this will be the focus of their expertise, whereas for me, it's just a very tangential topic. So it makes a lot of sense to look at who might have solved this problem the best, and then look at their solutions. The Idris example is a great example, because I'm an app developer. I have no idea of type systems beyond like the user level. I would never come up with dependent types, but I can spend 2 evenings reading 60 pages in this book and understand the gist. And I can use almost all the power of dependent types without that actually to come up with the concept. And then I have 3 modes of research with this mindset. One of them is exploratory, and this is where I basically just look at stuff totally unrelated to my field. The second one is targeted, where I actually research a specific topic based on the problem I'm trying to solve. And the last one is collaborative. And this one is not necessarily separate from the first 2, but it's so much more efficient working with other people that I broke it out as a separate point. And I'll go over these real quick separately. So with exploratory research, what is my goal? It's really expanding the horizon beyond things that I'm doing at work today. ReSwift and Validated are 2 examples of that. I didn't go out and learn about Redux because I thought it was a great tool. I just happened to stumble upon Redux, and then I used it for iOS development. Because I explored, and I looked at other talks, and I talked to other coworkers on other platforms. And what I do here is I usually spend a very small amount of time trying to grasp the core idea of a technology. As I said, with Idris, 2 evenings were enough to understand dependent types. It's not a very complex topic. So you can spend a little bit of time across a lot of different technologies, and you can really expand the scope of your knowledge. And as I said earlier, you begin to see connections between seemingly unrelated areas. And if you're really good at this, then you can take ideas from a database and apply them to your UI framework. The second one is targeted research. And this is what I use at PlanGrid at work most of my time. And here the goal is really to avoid previous mistakes. The assumption is that I'm trying to do something. One recent example is client-server synchronization. Then I assume someone must have done this before, because it's a very common problem. And so I go out and I research other solutions, and I usually define a budget based on how long I'm going to work on this project. For client-server sync, I knew it's going to be like half a year. So doing 2 or even 4 weeks of research without any productivity is totally fine, because it's going to pay off. And so I pick 2 to 5 options usually. These are, if you think back to that graph, the blue dots. And then I read, I prototype, I evaluate each of these solutions, and I repeat that for everyone. And I'm going to talk about prototyping in a second too, because that's a really important part of this. And lastly, there is collaborative research. And their goal is really to just quickly gain insight out of your area. And this is the lowest hanging fruit. It's just, if you run into an Android developer in your company or the conference, just use the chance to ask them questions. Like, I have this problem on iOS, how do you solve it on Android? And when you do such question answer things, you can actually learn a lot with very, very little effort. So just put some effort into meeting other people from other communities. And even though I'm promoting this, I'm still not as good at it as I'd like to be. Inside of my company, we're still working on improving the collaboration between Android, iOS, and even our Windows team, which we have. So these are the 3 modes of research that I use. But I also want to promote the idea of prototyping, which has really been a big game changer for me. I've been doing much more prototyping in the last 2 years. And one big driver behind that is Swift Playgrounds. If you're an iOS developer, you know what Swift Playgrounds are. But essentially, they are a REPL combined with an IDE. So if you work in Python or Ruby, you probably already know the concept of a REPL, where you can just program without actually compiling, and you get very quick feedback. But with Swift Playgrounds, you can do that inside of an IDE. And it allows you to really write bigger pieces of code inside of this context. And this allows you to prototype a lot of different things. Initially, I didn't think about it, but after I got better at this, I started prototyping things like client-server communication, all just in Swift. So when I went off and implemented client-server synchronization, I looked at operational transformation. I built a very simple version of it, all in Swift, where the client and the server were just objects communicating with each other. It is a really great way to evaluate a concept that you're trying to understand and try to use in your project. And I'm also a big promoter of kind of the idea of writing is thinking. So if I write a blog post, then I really spend a lot of time getting the details right, and I rectify a lot of my thoughts. And for me, prototyping is exactly the same for code. Another great thing about prototyping, and that's the last thing I want to mention, is you can reach this point of no return. We have proved that something is going to work with the prototype, and you get so excited about it that the implementation is really, really simple. So prototyping is great, and I think we all should do more of it. This brings me to a conclusion. I started out with 2 assertions, and I'm going to end with 3 conclusions. The first one for me is don't narrowly focus on immediate productivity. Invest time in research, learning, collaboration. Look outside of your box. You can make small investments that pay off quickly. And here I really want to pronounce the small investments that pay off quickly, because I hope that my example showed that I don't spend a huge amount of time. I don't spend like 2 days a week looking at other solutions. It can be a very small amount that exposes you to the core idea that you can then adopt. Conclusion number 2, reinventing the wheel is great, but starting from scratch would be foolish. This talk was not about using third-party libraries instead of writing something from scratch, but it was instead looking at other people's ideas. If someone else has implemented this before, they will have run into problems. Ideally, they open source the code, maybe they open source the paper. Look at that evidence before you start implementing your own solution. Implementing your own solution is great, but make sure you learn from the lessons that other people have shared. And conclusion number 3 is that stealing is a foundation for innovation. And I hope that the Apple example showed that. Apple is a company that has been doing this over and over again. And I think it will make you more effective and more creative, and it will accelerate the rate at which you gain experience. And I think if you're lucky and improve this as an entire industry, then we can become much more productive as developers by sharing tools and sharing ideas between platforms. That's almost all I have, but I have a small funny anecdote. I gave this talk internally at my company. And then after I gave the talk and finished, someone pointed out to me that there's a talk that is very similar. It's called Steal Like an Artist. And the funny, if the irony doesn't strike you, is that I apparently didn't do my research very well when I prepared this talk. But I actually watched a talk, and it's fairly different, but it comes down to some similar ideas, but it's not focused too much on technology. But yeah, this is all I have. I hope you steal more in future, and I hope you got some valuable lessons out of this.
Do we have some questions?
Thank you for a very inspiring talk. You said about looking for the academic papers to get some good ideas. What are the good sources of academic work and, let's say, approachable academic work? Because this is very closed community usually.
It's a great question, almost as if I had staged it, but I didn't. In the blog post that I linked to, where the guy that implemented PROIDEA talked about how he read papers, he links to a repository called Papers We Love, as like maintained by software developers. And these are all very practical, and they're grouped into like different sections. And there's even a meetup group in a lot of cities called Papers We Love local chapter, where people meet and discuss these papers. So the GitHub repository, Papers We Love. That's very good. And I recently subscribed to a newsletter called The Morning Paper. It's a fellow who reads one paper every single day, which is crazy to me, and then summarizes it. But it's also a really, really great source because it gives you the gist without that you have to read the paper yourself, which is awesome.